The next screen, load definition. This is what circuit type you're connected to. The PQube 3 is associated current sensor I1, I2, and I3 with a 3-phase load connected to L1, L2, L3. And this load name will be defined on the website as a tab as mains. If you're configuring your PQube to have more than one 3-phase load, by clicking this button, it associates I6, I7, and I8 with L1, L2, L3. And this here is called 3P-LD2, or it can be renamed to whatever you like. Just going to change them to load 1, load 2. I4 and I5 are reserved for neutral and ground current measurements. Next, AC voltage. This is what circuit we're connected to. By default, it's all auto on this page, and the PQube will attempt to identify the circuit you're connected to. However, if you know what circuit you are connected to, you should select it from here. For example, if you're connected to a delta circuit, it is possible the PQube when it starts up to misinterpret it and connect as a Y. Our circuit today is going to be a delta. Do we know the nominal voltage for our delta circuit? The PQube checks all standard voltages. If you have a different one in between, you would want to insert it here. As we run 480 here in US, we're going to put 480 there. There is no phase to neutral voltage here. It's being grayed out because I selected delta. Also in the voltage recordings, the phase to neutral channels has been grayed out because it won't be recorded because there is no phase to neutral in delta. If we have a Y circuit, these are now enabled. So we can turn these, leave them auto or on, or perhaps you did not want to know the phase to neutral channels in your Y configuration and you can turn them off. This just shows the flexibility of what is recorded at the PQube. Going back to delta. The PQube can be connected directly to a high voltage circuit. 480 volts is just fine. However, if I was connecting to a 4160 device, I can't connect that directly to the PQube. I'd want to enter some sort of ratio for the potential transformers being used. A common ratio for 4160 is 4200 to 120 volts. The applied voltage to each PQube channel will be 120 volts, but the real voltage inside of the PT is 4000. The advanced features here are recording voltage unbalanced using the particular IEC method, or other methods can be chosen. Record 10-second frequencies, harmonics, record the 200 to 150 kilohertz conducted emissions, and which way the vectors are rotating. In California, we rotate counterclockwise. Record flicker and what flicker frequency you're operating on, 50 or 60 hertz. If you have a missed wire and you've realized after you connected the PQube that L2 is really L1 and L1 is L2, you can go and rewire the PQube, which is what I would recommend, or you can switch them around here. This physically changes the connections of the PQube for you inside the PQube. I'm going to leave them as they were. The PQube is now set up and ready to run. If you put this installation file on your PQube, it will measure and trend voltages for you.